In this video, we are going to learning about our next topic, analysis of covariance. Unit is also called as ANCOVA, which allows to compare one variable in two or more groups. If you are taking into account or to correct for the variability of other variables, they are called the covariates. The analysis of covariance, you can say it can combines one-way or two-way analysis of variance with linear regression. You can say it's generally the GLM. So let's move on another slide. Analysis of covariance is used to test the mean and iteration effects of categorical variables. These contain some effects. You can say it is the interaction effects which have of a categorical variables on a continuous dependent variable, controlling for the effects of selected others continuous variables which covary with the dependent. So these effects can controlling for the effects of selected other continuous variables, and further they covary with the dependent. It is used in examining the differences in the values of the dependent variables that are related to the effect of the controlled independent variables, while taking into account the influence of the uncontrolled independent variables can be done in this. So it is related to the effect and then the controlled independent variable, while if you are taking into account the influence of the uncontrolled independent variable. It is a method of comparing of data that consist of two variables. So in this we are going to comparing the sets of data that consist of two variables, as there is the treatment and effect with the effect variable and being called the variate. So when a third variable, which is called the covariate, exists, and then it can be measured but not controlled, and that has a definite effect on the variable of interest. So this could be done in this while comparing the sets of data. In other words, it provides an indirect type of statistical control, allowing the precision of a study to be increased and potential source of bias to be removed. So it provides an indirect type of the statistical control, and then they allow a precision of a study, and it can be increased, or you can say the potential source of bias which to be removed. So this is it in the analysis of covariance. Further, we are comparing sets, we are using another function, and the differences in the mean values of dependent variables. And then it provides an indirect type of statistical control, and further we know that is a source of bias to be removed. So further moving, we have both ANOVA and ANCOVA with the variance and covariance, and both are used to check the variance and the mean values of the dependent variable associated as a result of controlled independent variables. After considering the consequences of the uncontrolled independent variables, it can give you the output. So first we have the ANOVA is an effective technique for carrying out research in various disciplines like businesses, economics, physiology, biology, and education when there are one or more sample involved here. And in ANCOVA we have covariance, which is blend of analysis of variance, which is of ANOVA, and regression. It can tell you what additional information you can get by considering one independent variable, that is the factor, at a time without the influence of other. So if you are using this, you can get additional information at a factor at a time without the influence of others. Here it's different use. It can be used as an extension of multiple regression to compare multiple regression lines. You said there you can compare the multiple regression files, and extension of analysis of variance. It can also be used as an extension of the analysis of variance. So here it is the difference of both ANOVA and ANCOVA and its different uses, how it can be used as. So let's move on next. Assumptions of ANCOVA. So these are the different assumptions. First we have independent variables. Minimum of 2 should be categorical variables. So if you are using this, you have to give minimum of 2 categorical variables. Next, dependent variable and covariate should be continuous variable measured on an interval scale or a ratio scale. Make sure observations are independent. So here the dependent and covariate should be of continuous variables and measured on an interval scale or ratio scale. Software can usually check these assumptions as normality. The dependent variables should be roughly normal for each of category of independent variables. The data should show homogeneity of variance. Next, the covariance and dependent variables, which is at each level of independent variables, should be linearly related. So it can be related as linearly if you are using it, and the data show the homogeneity of variance. Next, your data should be homoscedastic of y for each value of x. Yes, it was homoscedastic if you are giving for y and for each value of x. Next, the covariate and the independent variable shouldn't interact. In other words, there should be homogeneity of regression slopes. So the covariate and the independent variables, they wouldn't get interact between, and it also provides a homogeneity of regression slopes. So these are some software assumptions. So I hope you guys learn about analysis of covariance, its different assumptions, ANOVA and ANCOVA, and also the software assumptions in it. So that's all in this video. Thank you.